Hello team, welcome back. And today we will start a new section. In this particular section onward, we will learn about the Docker Swarm. So till now we have discussed about the containers, images, Docker. From this section onward, we will learn about the Docker Swarm, right? So we will see what is Docker Swarm, we will see what is the application of the Docker Swarm and how we can use the Docker Swarm in our production lifecycle. So let's start with. So first, we will go through some problem statements which will be resolved by the Docker Swarm. So team, we have also learned about the containers. We have seen how we can use the containers to run our application in isolation, how the containers are helpful, and how we can execute the multiple containers on a single machine, right? So now the question comes in, why we need Docker Swarm? What is Swarm? When we have already discussed about the containers and containers are resolving a lot of issues, then what is the Swarm? Why we need Swarm? So Swarm is basically used to cluster your Docker containers. So why we need to cluster the Docker containers? So we have a few questions, and these questions will help us to understand the need of Swarm. So this is the first problem statement, how we can scale up the containers. So team, as we know, the things are moving internet very rapidly, and in current time we have a lot of robust and lot of agile applications. So the traffic to any application can divert anytime. Suppose you are owning some e-commerce website, like suppose you are owning Amazon, Flipkart and Snapdeal kind of website, or you are owning the website like Netflix, Amazon Prime, right? And at runtime you are going to launch a new sale, you are going to launch a new web series. So at that particular time you need a lot of resources available in your pool. So the one possibility is you will put a lot of engineers and they will create the container at runtime, right? And they will manage the load. And the another mechanism is you can automate your infrastructure, right? You can scale up your containers dynamically as per the load. So this is the first problem statement where Docker Swarm is going to help us. The second thing is how you can manage your containers, or you can recreate if they fails or crash. So your container is working and suddenly it stopped working, right? It crashes. So how can you manage that particular container? So this is the second statement where Docker Swarm is going to help us. Suppose you are running 4 containers in a production. The first container is active container, second one is the passive container, and two other containers are the replication server, right? Somehow your replication server goes down, right? Now replication is not happening between your primary application and your secondary servers. So in that case, how your application will behave? It may possible that your application will crash or your application will stop responding, right? So how we can manage these kind of situations? How we can recreate the containers if they are crashing or they are fails? So this is the second problem where Docker Swarm is going to help us. And the third is how we can upgrade the services with zero downtime. So you are executing a service in a container and these containers are running in the production. So you want to upgrade your container. Suppose you are using Tomcat 801 and you want to upgrade Tomcat from Tomcat 801 to 803, right? But you don't want any downtime. Downtime means your application in the production will not be down for any single second, right? So how you can manage the upgrade of services with zero downtime? This is the third problem statement where Docker Swarm is going to help us. How you can manage the containers, the number of containers on VMs on Docker engine, right? So how the infrastructure is going to identify, okay, that particular node have a lot of containers, and to put more containers on the same node will be problematic. So how we can manage the containers on the VMs and nodes? This is the another problem where Docker Swarm is going to help us. So let's move further and let's see what is the Docker Swarm and how we can use the Docker Swarm, right? So Docker Swarm is clustering and scheduling tool for the Docker containers. With the help of the Docker Swarm, you can orchestrate or you can make the cluster of your Docker containers. With the help of the Docker Swarms, we can schedule the task, we can schedule the services, right? So let's move further and we will see how we can create the cluster of the containers, how we can schedule the task, how we can schedule the services. And the another point is Swarm is Docker's native support, right? It is a native support of the Docker. This is not a third party tool or third party service which we are executing above the Docker. So Swarm is the Docker native support for the orchestration of the clusters and Docker engine, right? When we are talking about the orchestration, what is the orchestration? So orchestration means define nodes and define services. See how many nodes you want to run and where you are done, right? So orchestration means at runtime we will define the number of nodes and the number of services are running on these particular nodes, and we will see that how many number of nodes are basically required at runtime and where these nodes will be deployed. So this is called orchestration. Docker will help us to orchestrate the containers on the Docker nodes. At a high level, we can say that Docker Swarm takes multiple Docker engines running on different host machines and let us use them together. So we can understand this particular thing with a simple example. Suppose we will take an example of the Amazon.com, and Amazon.com has launched, and Amazon recently has launched a new service, Amazon Prime, right? Amazon Prime is operational in multiple countries. In suppose, and many countries have a lot of population, like India have a lot of population, China have a lot of population, US itself have a lot of population. So we need to scale our services as per the requirement. Amazon is going to launch a new web series which is quite popular in India, which is quite popular in America, right? So the people, so the load which we are expecting on that particular servers when we will launch the web series is quite high. So in that case, on the peak load hours, Docker Swarm will help us to manage the Docker engines, manage the Docker containers, and it will decide on which host I need to up new containers and how we can manage them together, right? So at runtime, user is sending the traffic, but on which node that particular traffic will diverse, it is the responsibility of the Docker Swarm. Docker Swarm have two types of node. The first node is called manager or master, and second type of nodes are called worker. Every swarm starts with one manager node, or we can say it's a leader node, right? The algorithm which Swarm is using is called the Raft algorithm, right? So Docker Swarm is highly available, which is just because of the Raft algorithm. Now we will see what is the Raft algorithm. So Raft algorithm has been designed in a particular way that the leader node is constantly checking it with its follower nodes, right? And syncing their state with the follower nodes. So in the Raft algorithm, we have one master node and we have n number of follower nodes, right? The master node is checking their state with the follower nodes. In any case, if the master node goes down, then the one of the follower node will create as a master, right? We can understand this particular thing with a simple example. So let's say we have three nodes like A, B, and C, and A is the leader, right? One day in the network transaction, the A goes offline, and B and C are alone, and B and C are not getting any call and not getting any traffic from the A, right? In that case, with the help of the Raft algorithm, B and C will elect one of them as a master and one of them as a worker, right? So suppose B is picked as a master, right? Now B is serving as a master, C is serving as a worker, A is offline. After some time, A comes online, right? But when A goes down, it was a master. Now A is master, B is master, C is worker. So what will be the state of A once it will come online? So in that case, A will identify, okay, B is the master in term 2. So A itself downgrade as a worker. Now B node will become a master and A and C will become a worker. So this is called the Raft algorithm, where master and worker nodes basically manage themselves, and once the master goes down, any of the worker node will come as a master and serve other node as a worker. Now let's discuss about few benefits of the Docker Swarm. So the first benefit is the task scheduling. So let's discuss how Docker Swarm will help us in the task scheduling. So suppose we have n number of services. So what we need to do, we need to deploy our services as a stack in a swarm, right? So we will create a stack of services in a swarm, and when you declare your services, you provide the swarm with important information about how you actually want your service to be run. This includes the parameter like how many replicas you want on each service, how the replicas should be distributed, when they should only be run on the certain nodes, and more, right? So once the service is deployed, now it's a job of a manager to ensure that the deployment requirement you set continue to met. It means if anyhow the service goes down, a new container will be spinned up. So let's understand this with an example. So let's say you have deployed an Nginx service, specify that there should be three replicas. So it means if anyhow your deployment goes down, it is the responsibility of the manager to spin up the new container with the same configuration, right? The second benefit or the second use of the Docker Swarm is load balancing. So how Docker Swarm will help us in the load balancing? So suppose your service is running and you are running 10 Nginx servers, right? In these 10 Nginx servers, one is the master and rest 9 are the workers. Now it is the responsibility of the Docker Swarm to maintain the traffic on all the Nginx nodes, right? 9 worker and one master node. It doesn't mean that the master will not serve the traffic. Master will also serve the traffic, but worker will actually serve the traffic. Master will manage these 9 workers plus serve the traffic. So load balancing is another feature of the Docker Swarm. The next benefit of the Docker Swarm is rolling updates. So if you are running as a DevOps engineer, then many times you have seen that at runtime we are executing 10 servers in a single application, right? And somehow some bugs found in the production, and we need to patch our production. And so in that case, Docker Swarm will help us to patch the running containers. In the Docker Swarm, you can define, okay, 2 containers at the same time will be goes down, and 2 new containers at the same time will spin up with the new patch. That means if 10 containers are running on application, then 2 containers will be spinned up with the new functionality, with the patch functionality, and 8 are still running with the old. So here you can see there is no downtime. Application is still running. There is user is not impacting, right? User is able to execute their work. It's just the responsibility of the application and load balancer that where it is sending the traffic. In the same way, we can again down the 2 another containers and upgrade 2 new containers, down 2 another containers and upgrade 2 new containers. So this is called blue green upgrade, and this is called the rolling upgrade or rolling update, right? Where without any downtime we can upgrade the services. This is also the functionality of the Docker Swarm. And last one is the security. So Team Docker Swarm comes with the great security features out of the box. When a node joins the swarm, it is uses a token, and that token is encrypted, which is basically decoded by the swarm itself, right? So it comes with a lot of security features as well. So team, this is about the swarm. We have discussed what is the need of the swarm, what is the swarm. In coming lectures, we will see how we can implement the swarm and how we can create the services in the swarm. So thank you team, thanks for your time.